Hello all. Previously we have seen all the insert operations in the single linked list. Now we will see delete operations in single linked list. So we are starting with how to delete a node at the beginning of the linked list. So with the help of a user defined function called deleteAtBegin. For suppose if head is equal to null, if head that is double equal to null, that means the linked list is empty. We don't have any node to be deleted, so we will return that. So no more lines of code will be executed in this particular case. Let us assume there are some nodes in the linked list, then how this function behaves. For that, we are declaring one pointer called temporary pointer, which is initially placed at the beginning of the linked list. And then we will move the head pointer to the next location, that means the second node, and we are freeing the temporary location, that means we are freeing the first node, because initially head is pointing to the first node and temp is also pointing to the first node. Now we are moving the head location to the next node and we are freeing the temporary node location. So that means we are deleting the first node, right? So let us assume a linked list as follows. So we are having three linked lists, 10, 20 and 30, and their addresses are 50, 100, 200. They are interlinked with the address part. Now let us assume deleteAtBegin is called on this linked list. So how this function behaves? Let us see that. Is head double equal to null? But head is pointing to the 50th position, that means head is pointing to some location there. So this is not true, so this is skipped now. For now we will create one temporary pointer and we are assigning temporary pointer to the first node. So after executing this line, this is the linked list diagram. Head and temp both are pointing to the first node. Now we have to move the head pointer to the next location, that is the second node. How do we do that? Head is equal to head, arrow next. What is the head next location? 100. Now head will be moved to the 100th location, that means 100th memory location. So in this case that is second node. So what is the updated diagram? So temp is pointing to the first node, head is pointing to the second node. Now we are freeing the temporary node, that is the first node. Free is a dynamic memory allocation function which is deallocate the memory from the heap. That is the meaning of it. Now temp is deleted. What is the updated linked list? How it look like? So 100 and 200 are the memory location. Head is pointing to the second node, that will become the first node eventually. So this is how the deleteAtBeginning function will work. And we have not checked the condition, what if head double equal to null. That is very trivial. If there are no nodes in the linked list, the head will points to the null location, then no more nodes, no more deletion operation is required in that case. So now let us see how we can delete a node at the end of the linked list. For that we are using a user defined function called deleteAtEnd. As I said earlier, if head double equal to null, that is means linked list is empty and no more nodes to be deleted. What if head next is double equal to null? That means the linked list contains only one node. This function will work. In that case, we are directly delete the head node and head will point to the null. That means linked list is empty. To indicate linked list is empty, we are writing head is equal to null. First we have to free the head and we have to assign null value to the head. That means linked list is now empty, and then we can return. What if there are multiple nodes in the linked list? How the deleteAtEnd function will work? Let us see that. For that, we are taking 2 pointers extra. One is priv, another one is current. Priv is initially pointing to the null. What is the significance of priv pointer here? It will track the second last node. Okay. And current, what is the significance of current node here? It will track the last node. Okay, so current pointer will point to the head location initially, and a priv is pointing to the null location initially. We have to traverse these 2 pointers so that current pointer will move to the last node, and priv will move to the last but not one node. That means second last node. Okay, now let us see how the things working in the code. Instead of going through each and every line of the code, we will see one example that will be easier to understand. So let us jump to the example directly. So let us assume linked list as follows. We are having 4 different nodes. Their addresses are 50, 100, 200 and 300, and they are having the values 10, 20, 30 and 40. 40 is the last node as of now. So that 40, whatever you are seeing right now, this needs to be deleted by using this function called deleteAtEnd. Okay, so as I said earlier, we are declared 2 pointers. One is priv and another one is current. Initially priv is pointing to the null, and current is pointing to the head. So that is what our expectation is. Now traverse current and priv pointers accordingly. So by the help of this loop called while loop, current next, what is the current next address? It is 100. Is 100 not equal to null? The condition true. We are in the while loop. So we are traversing these 2 pointers now. So priv is equal to current. What is the current value? It is 50. That will be assigned to priv. So priv will eventually move to the first node. That is the expectation. So head, current, priv, both all 3 pointers are pointing to the first node. So there is another line in the while loop also, that is current is equal to current arrow next. What is current next value? It is 100. That will be assigned to the current. So eventually current will move to the next node. That is the meaning of it. So what is the updated diagram looks like? So now initially current is placed at the first node. By the end of that line, current is pointing to the second node. Now we are moving to the next iteration. Is current next not equal to null? Current next is 200. Is 200 not equal to null? The condition true. Now we are in the while loop again. Priv is equal to current. What is the current address? Current address is 100. That will be assigned to priv. And I'm not drawing the diagram. So after performing this step, I have drawn the diagram. Let us see the next step also. So current is equal to current arrow next. What is current arrow next address? That is 200. That will be assigned to cur. So cur will move to the next location. So what is the updated diagrams looks like? So head is pointing to the first node. So as you said, as we discussed, priv is pointing to that 100. So that is what reflecting here. And current is moves to the next node. So current is moves to the 200th location. Now we are at the final iteration. Is current next not equal to null? Current next is 300. Is 300 not equal to null? Condition true. So we are in the while loop again. So priv is equal to current. So priv eventually moves to the 200th location. That is the expectation now. So current is 200. That will be assigned to priv. So what is the updated value in priv? 200. So now current is equal to current next. What is current next value is 300. So initially current value is 200. Now current value will move to the 300. So current pointer will move to the last node in this case. So this is the updated diagram looks like. So previous is the second last node. and current is the last node. So we have traversed all the pointers. Now let us see the next iteration that eventually becomes false. Is current next is null? Is null not equal to null? That is false. Now loop is terminated now. So after loop we have following statements. Now we will directly delete a current pointer, free current. That means we are deleting the last node. And this whatever the priv, that is the second last node, that address part should be assigned with null. So priv next is equal to null. Null will be assigned to priv next. This is the updated diagram, 50, 100, 200. This is the second last node, by the way. That becomes the last node now by this null assignment. But if we have not checked a condition, what if a linked list contains only one node? At that time, this if condition will work. If head tends to next double equal to null, that means the linked list is having only one node. How deleteAtEnd function will work in this case? That is a homework for you. Okay. So now let us start with how do we delete a node at a specific location by using a user defined function called deleteAtPosition that takes one argument. So that argument is the position value. What if head double equal to null? That means the linked list is empty. We don't have any nodes to be deleted. We are returning to the function. That means the function execution is got completed. What if there are multiple nodes? In that case, how this function works, let's see. For that, we are declaring one pointer variable called temp. That temp will be assigned with head value. So head and temp both are pointing to the first node. Now if you are trying to delete a node at the location number 1, that is the deleteAtBeginning only. If position double equal to 1, that means you are trying to delete a node at the beginning only. So whatever you have coded in the deleteAtBeginning function, that will reflect here. So we have to move the head pointer and we have to clear the temp pointer. This is as same as deleteAtBeginning function. Okay. Now what if there are multiple nodes? Now you are trying to delete a node at a given position. How this function works, let us see. For that we have to take one more pointer called prev. That prev initially assigned with null value. Now we need to take one loop variable called I, whatever, it's your choice. So now we have to traverse these pointers. I is equal to 1, temp not equal to null, and I less than position. Instead of going through each and every line of the code, let us take one example and I will explain through that example. That will be better. Okay. So let us assume a linked list as follows. We are having 4 different nodes, 10, 20, 30 and 40. Now I want to delete a position 3. That means so this 30 needs to be deleted. Now how this deleteAtPosition, the working nature, how this function works, let us see. So priv is equal to null and temp is equal to head. Initially priv is assigned with null value and temp is assigned with head value. So temp is pointing to the first node and priv is pointing to the null value. So we are in the loop. By the way, these conditions will be skipped now. So head double equal to null, that is not true in this case because we are having some nodes here. And position double equal to 1 is also skipped because position is 3 now. Okay. So this code I have not written here, but that parts will be skipped now. So we are at the traversing part. So temp not equal to null. What is the temp value? 50. Is 50 not equal to null? True. And what is I value? I value is initially 1. is 1 less than 3, condition true. Both the truths, that means logical and returns true. So we are in the loop. In the loop we have two statements. First one is priv traversing, another one is temp traversing. Let us see how it goes. So priv is equal to temp. What is the temp value? Temp value is 50. That will be assigned to null. So after this line, null will point, priv will point to the first node. And after that we have to traverse the temp pointer by the help of this statement called temp is equal to temp arrow next. What is the temp next value? 100. So 100 will be assigned to temp, so that temp will move to the second node. So this is how the updated diagram looks like. So head and priv pointing to the first node, and temp is pointing to the second node, that is the 100th location in this case. Now I becomes 2 because I plus plus. Now we are in the second, next iteration. Is temp not equal to null? Temp is 100. Is 100 not equal to null? Condition true. I becomes 2, right? In the previous case. Is 2 less than 3? Condition true. Again we are in the loop. Now we have to traverse these pointers, right? Priv and temp pointers. So priv is equal to temp. What is the temp value? 100. So now priv will move to the second node. And we have to traverse the temp to the next node, right? By the help of this statement, temp is equal to temp arrow next. What is temp next value? 200. So the temp will move to the 200th location. So this is how the updated diagrams look like. Priv is pointing to the second node, temp is pointing to the third node. Now I becomes 3. Okay. Now we are end of the loop. Let us trace that one as well. Now I becomes 3. Okay. Temp not equal to null. Is temp not equal to null? Temp is 200. 200 not equal to null? Condition true. But I becomes 3 in the previous iteration. Is 3 less than 3? Unfortunately false. Loop is terminated now. So after loop, by the way, after this loop we have a diagram like this. Please remember this. And after loop we have one statement called if temp double equal to null. Eventually this is not the case, because temp is pointing to some valid address, 200th location. So that means we will be skipping this part. Okay. Now after this condition we have another statement called priv next is equal to temp next. What is temp next address? 300. That 300 will be assigned to previous next. Now let us see the diagrams. Initially after for loop iteration, this is the diagram. Now we have to perform this step, right? Priv arrow next is equal to temp arrow next. What is temp next address? 300. This 300 is to assigned with the previous next value. So this is the updated diagram. That whatever the third node, that link will be missing here because of this assignment. So temp next address is 300, that is assigned with the second node address. So that link is no more here. Now we are free to delete this temp by the help of free function, free of temp. Now temp got deleted, so that is no more valid location. So this is the updated part. 1, 2, 3, and the third location got deleted. Okay, that fourth location will be the third node eventually. But we have not checked the following conditions. What if position double equal to 1? That is similar to delete at the beginning code. And what if temp double equal to null? For suppose we are having 4 nodes in this case, right? Now you wants to delete a node at the 6th location, but the 6th location is not there. At that time temp double equal to null will come into picture, and you will have a message called position out of range. That is the working nature. Please try these conditions on your own. Let us try to run this code in devcpp. So this is the full code insert and delete operations with the menu driven. Menu driven in the sense in main function we have insert at beginning. So we have a choices here, that is a menu driven program. Okay, now let us try to run this code. Execute, compile and run. So initially the linked list should be present, right? So 1 can add 10. I will add 20. I will add 30. So that means 30, 20, 10 will be the linked list. Now I want to delete the node at the specific location, that means 2. Before deleting, I want to show the linked list so that I'm going to display the list now by choice 8. Now what is the linked list now? 30, 20, 10 and null. 1, 2. Now I want to delete this 20. Okay. So what function we have to choose? Delete at specific position. So 6th we have to choose 6th. So enter position to be deleted. This is 2nd. That is deleted. Now I will show you the updated list. Updated linked list by the choice called 8. Now see, 20 got deleted. That means the second node got deleted. So that's it. Please try to execute other 2 codes as well. That's it for this video. I will see you in the next video. Thank you so much.